So we're going to solve the circles, and we're going to talk about graphing it, and we're going to also solve some functions and define its domain and range. So let's start with the circle first. The formula for the circle is going to be x minus h, and I apologize, my computer is slowly catching back up. Okay, x minus h squared plus y minus k squared equals r squared. So I'm going to talk just a little bit about it. So the h goes with the x because the h value is representing the x, right? It's representing the center of a particular circle or parabola or whatever we may be, ellipse, a hyperbola that we're going to graph. So my center is h, and then k is going to be my y value. So h comma k gives me the center of this circle. So here we go. We got 1 and negative 6. So let's rewrite this right here. And let's plug in our points that we do know so far. Alright. And let's talk about r for a minute. R is the radius. Basically means it's going to be from the center out. Right? It's the radius from the center of the circle out. So r is my radius, and here we have 8. Alright, so now let's plug in. So x is 1. The y value is negative 6, so negative times negative gives me a positive. Now this is not my final form. We do not answer it this way because we still got to square this 8. So my final format would be x minus 1 squared plus the y plus 6 squared. And then 8 squared is the same as saying 8 times 8, which is 64. Now, I want to go back to explaining about the radius a little bit by actually graphing it for you to give you an idea. I'd have to use a really big graph in order to get these points on here, but I'm going to do the best I can. My center of this circle is 1, negative 6. So I'm going to go over here and start at 0, 0, and my x value is positive 1, so we're going to go over 1, right? So let's call this 1 right here. And from there, my y value is negative, so I want to go down 6. So let's go 1, 2, 3, 4, 5, 6. And we need to make sure it lines up with where x is 1. Alright, so here's my center. The radius is telling me that it's so many places away from the center. So if I go to my radius and I notice it's 8 before I square it, then that means I need to go up 1, 2, 3, 4, 5, 6, 7, 8. So right here. I'm going to go back to my center and I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. I'm going to plot it here. That means I'm going to go down from this center. 1, 2, 3, 4, 5, 6, 7, 8. Let's plot it. Go back to the center and go to the left. 1, 2, 3, 4, 5, 6, 7, 8. Now, I didn't use a graph I already made on a grid, so it's not going to be a perfect looking circle. And now that I've done that, I can connect these dots and I have my circle. And again, I should have used a graph that already had a grid on it. It's not a real good drawing. But y'all kind of get the idea of what I'm trying to say about the radius. The radius is how many steps away from that center. So let's talk about a function. Let's talk about its domain and range too. What I notice here is I have this absolute value. We had talked about if the power is 1 on the x or y, then that means we have a linear equation. If it has a power of 2, we have a parabola. If both of them has the power of 2, you notice we got a circle, right? Well, in this case here, we have absolute value. The absolute value is actually going to give us this really sharp looking V. It either opens down or upward or to the right or left. And in order to determine how to plot this on the graph, I would like to create a XY table. And I noticed that it is already set up equal to Y, right? This G of X, the function name is G, and that's actually my Y value. So I'm going to plug in points for X. So let's plug in -1, 0, and -1. This should be enough. If not, you can always plug in more. So I'm going to solve for when X is -1. So we got absolute value of -1 minus 1. Whenever we take the absolute value of something, when it comes out of those value signs, it becomes positive. So I got +1 minus 1 gives me 0. Now let's plot the next order pair. Whenever I take the absolute value of 0, well, that's just 0. 0 minus 1 is just what? 1. And I apologize, I got -1 on here twice, so let's make this a +1. And whenever I plug this +1 in the absolute value, I get a +1 out, minus it gives me 0. So let's come over here and start at 0, 0. And you notice that we have this order pair right here, the 0, 1. So Y is 1, go up, plot it. Alright, go back to 0, 0, and let's plot where X is -1 and Y is 0. And let's go back to 0, 0 and plot where 1 for X and 0 for Y. And it is a really sharp V looking. And you put arrows on the end saying it's continuously going. Now we need to state what is the domain and range. Well, the domain is my X values. Okay, it's my X values, and we always read our X values left to right. So when I do that, what do I see? I see this arrow here is going out like this on the negative values. So that means it's going to eat every one of those negative values for my X. So I know that I have negative infinity. Now, let's keep on reading it. So when we follow the line, follow the whole entire line out to the next arrow, it goes continuous out, and it's going to eventually eat up all the positives. So my domain here is all real numbers. It's negative infinity to positive infinity, or you can call it all real numbers. Now, let's look at the range here. The range is my Y value, and we always read bottom to top. Let me put this on here. And when I'm reading this here, I'm looking, all I need is one of these lines, one of these sides of these lines to have an arrow on it. That's all I need. That means it's going down here and it's going to eat up all my negative values for my Y. Okay, now I'm going to follow this out, right? We're going to follow this out all the way up to right here. You see that little circle there that we had drawn? That started at this order pair of 0, 1. That tells me that this line actually stops there, and it stops at 1. So therefore my range is negative infinity to positive 1, and you put a bracket on the positive 1 because it stops on 1. It don't go any further. However, you cannot put a bracket on negatives or positive infinities because you cannot stop infinity. So next, let's talk about the domain and range of this function. Or not the range, apologize. Let's talk about the domain. The reason why I say not range is because we're not graphing this one. These two here, the last two, we're not going to graph them. So I just want to know what is the domain of it, okay? Well, looking at h of x, I noticed that it's a fraction. And my domain is going to tell me that whatever causes the denominator to have 0, which is an undefined function, then I'm going to have a domain. I'm going to have some restriction. So that's the part I need to focus on when I'm looking for the domain. And again, we don't need the range if we're not graphing this. So if you're asked to give the range, you need to graph it to see where it goes. Okay, so what I'm going to do is take the denominator, and I'm going to set it not equal to 0 because I don't want it to be 0. And whatever answer I get, that tells me that's the restriction, right? So now let's solve for this. Alright, so I'm going to solve. I'm going to say x plus 5 not equal to 0. That means I got to subtract the 5. So this tells me that x cannot equal negative 5, because if it does, what happens? I get a undefined function. Now let's come over here and add, look at this x minus 10, and let's add it to both sides. And x cannot equal 10. Because if it does equal 10, then that means that we get a 0 in the denominator and it becomes undefined. So what I want to do now is state my domain, state the restriction. So if I was to draw this on a number line, I know I got this point here at negative 5. I'm going to put an open circle because we can't include that negative 5. And I'm going to put an open circle at 10 because we can't include 10. If I put a closed circle, we're including them, okay? So what this tells me is that I can use all points smaller than negative 5. I can use all points between negative 5 and 10, and all points greater than 10. I just can't use negative 5 and 10. So my domain statement will look like this. It will be negative infinity, comma, negative 5. And I'm going to use a parenthesis on the negative 5 because I can't include it. I'm going to say it's going to union negative 5, comma, 10. Again, a parenthesis because we can't include 10. Union 10, comma, positive infinity. And that is my domain, and it's because it's a fraction, it has a restriction. Now, let's do our last one. Our last one says we have k of x is equal to the square root of x plus 4. A little side note. If you're taking an odd root, right? And when I say odd root, we got like cube root, fifth root, the odd root. Then my domain is all real numbers. It don't matter. Because I can have negative, I can have positive numbers as a result from solving these, and that's fine. But if I have an even root, the square root, the fourth root, so on, you'll kind of see the point, then I'm going to have a restriction. Because you cannot multiply something an even amount of times and get a negative answer. So this is a special case. So what I do is whenever I'm looking for my domains, I look, is the root even or odd? If it's odd, it's going to be all real numbers. If it's even, then I got to do some work. So what you got to do is take the radicand, and the radicand is the value that's underneath the root. And in this case, the radicand is x plus 4. We're going to set it greater than or equal to 0. And then I'm going to solve. And I have to minus the 4 from both sides. And it gives me x is greater than or equal to negative 4. I want to give you a little side note. If it was say a negative x on there, and we need it to be a positive because you can't have the negative on there. You got to have a coefficient of positive 1 in order to tell you what x value is. That means we'd have to divide by that negative 1. And whenever you divide by the negative, this will flip this inequality sign, and it goes from greater than or equal to less than or equal to. So this is a little side note, just a little side note, just a reminder. Now back to this problem here. If I was to graph this on the number line, this said at negative 4, we are going to include it. Why? If I plug in negative 4 back into this function, Negative 4 plus 4 gives me 0. The square root of 0 is 0. So any root of 0 is 0, okay? So now I'm going to read this graph. It said x is all greater than value, so I know I'm going off in this direction. So now when I can write my restriction, my domain, I know I include the negative 4, comma, positive infinity. Remember, you always read left to right. And thank you.